So this exercise is related to wave. The learning objectives are there. So the whole exercise is having the question related to waves, interference, and formation of a standing waves. So in the first question, an electromagnetic wave within a vacuum has a wavelength of 8.4 exponent minus 4 meter. Which part of a spectrum it belongs to? You have to learn the range of the wavelengths for each type of wave. So when you work out, you will find it is infrared radiation or IR radiation. Calculate the frequency in terahertz. So how to work out the frequency? V is equals to F lambda. So F is V over lambda. V is the speed of electromagnetic wave and the lambda is a wavelength that is given to us 8.4 into 10 to the power minus 6. So when we divide, what's our answer here? So this will be 3.6 into 10 to the power 13 hertz. So we want to convert tera. Tera means 10 power 12. So if I convert into tera, I'll move this point one more place. So that this decimal will become 36 into 10 to the power 12 hertz. Because if we move the point toward left, we are increasing a power. If we move the point towards right, we decrease the power. So this will become 36 exponent 12 hertz, and exponent 12 means tera. This is a Young's double slit experiment. A laser light is there with a wavelength 6.2 exponent 7 with a spacing between the separation, slit separation is given A, and the laser light incident normally separated the slit and the screen. The slit and the screen are at a distance of 2.8 meters. So we observe the interference pattern. You can see bright or dark fringes are there. And 22 millimeter is a space between 1, 2, 3, 4, 5, 6, 7, 8 fringes. So 8 fringes have a spacing, so we can work out X. X is a spacing between the fringes. So X will be 22 millimeter divided by 8. That will be X. Now the question is what we need. What is meant by coherent? Again, as I mentioned, learned the standard definition. The coherent means the wave which is having the constant phase difference between the two waves. When they have a constant phase difference, we call them as coherent. Slit separation, if we need a slit separation, so lambda is equals to AX divided by D, or AX divided by So we need separation. A is needed. So A will be equals to lambda D divided by X. And lambda is a wavelength which was given 6.2 into 10 to the power minus 7 was given in the question. D is a distance between the slit and the screen 2.8. And X is the spacing between the fringe that we did like 22 millimeter divided by 8, or 22 exponent minus 3 divided by 8. So I can substitute here 22 into 10 to the power minus 3 divided by 8. Why? Because the 8 fringe spacing was given. So that will give us a spacing here, which is 6.3 into 10 to the power minus 4 meter. That is the spacing between the slits. (6.2 exponent minus 7 is a wavelength. That's a wavelength. D is a distance between the screen and the slit, and X is a spacing. X is a fringe spacing. No, it was not 8.4 in the question. It was given 6.2. Here the wavelength they give 6.2 exponent minus 7. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . The next is the fringe P is the central maxima. Fringe Q and fringe R are the nearest dark fringes and nearest bright fringe. So calculate the difference in the distance, the path difference actually. So look, what is the path difference? This is drawn in this plane. If we have a central maxima is there, then we'll have a minima, and then we'll have a minima again around, so from a central maxima, and then we'll have a maxima. So this will be a minima, then we'll have a maxima, and we'll have a maxima. So what is the path difference? Remember, the path difference here for central maxima is 0 wavelength. For first minima, lambda by 2. For first maxima, lambda. Same thing, here will be lambda by 2 and here will be lambda. The question is, we need the path difference for Q. So this is a central maxima, like example, this is P and this one is Q and then this is R. So what is the path difference for Q? Because it's the first minima, so the path difference is lambda by 2 for the first minima. The wavelength is given to us, which was 6.2 exponent minus 7. So if we need the path difference, how we can work out that path difference? It will be wavelength divided by 2. So wavelength was 6.2 exponent minus 7 and divided by 2. So we got 3.1 into 10 to the power minus 7 meter. That is the phase, that is the path difference. Is it clear, this one, the path difference? Then what about the phase difference? The phase difference, the same concept we use. Like example, we have maximas and minimas. The central maxima is there. Then we'll have a minima. Then we'll have a maxima. Then we'll have a minima. So the central maxima, the phase difference is 0. Then it will be pi by 2, the phase difference. And then it will be pi. It will be pi. The minima will be pi or 180. And then it will be 2 pi. Because the phase difference or the angle difference. So state the phase difference between the wave meeting at point R. So R is what? R is actually representing the first maxima, because if this here, so this will be 0, the phase difference, angle difference, 0. Then it will be pi. Then it will be 2 pi. Then what about this one? Because 180 is there. Like this is 180. When they're 180 out of phase, this is 0, 180, 360. Then 360 plus 180. You get 540. And then 540 plus 180, you will get 720. Like after every 180 phase, there will be constructive and destructive interference. So for R, the phase difference will be 360 degrees or 2 pi radian. The path difference will be 0, lambda by 2,